Welcome to AminAcademy.com. In Operation Research, let us discuss about linear programming model, some graphical solutions. Solve linear program by graphical method. A linear program can be solved by multiple methods. In this section, we are going to look at the graphical method for solving linear program. This method is used to solve the two variable linear program. If you have only two decision variables, you should use the graphical method to find the optimal solution. Graphical method involves formulating a set of linear inequalities subject to the constraint. Then the inequalities are plotted on XY plan. Once we have plotted all the inequalities on a graph, intersecting region gives us feasible region. The feasible region explains what all values our model take, and it also gives us the best solution. Let's understand this with the help of some example. Look at this example. A farmer has recently acquired a 110 hectares piece of land. He has decided to grow wheat and barley on that land. Due to the quality of the sun and the region's excellent climate, the entire production of wheat and barley can be sold. He wants to know how to plant each variety in the 110 hectares, gives the cost, net profit and labor requirement according to the data shown in the below. Look at here, the table is given. The varieties are wheat and barley. Cost price per hectare is 100 and for barley is 200. Net profit for per hectare for wheat is 50, barley is 120. Man days, that is working hours available is for wheat is 10 and this 30 for that is man day per hectare. The farmer has a budget of $10,000 and availability of 1,200 man days during a planning horizon. Find the optimal solution and the optimal values. Now let us discuss about further the formulation of linear problem. First, identify the decision variables. Here the total area of the growing wheat, that is X, is a decision variable for hectares, and total area of the growing barley is Y. Then X and Y are here our decision variables. Now write the objective function. Since the production from the entire land can be sold in the market, that means full land can be cultivated. The farmer would want to maximize the profit for his total produce. We are given net profit for both wheat and barley. The farmer earns a net profit of $50 for each hectare of wheat and $120 for each barley. That means net profit for barley for each hectare is 120 for barley. Our objective function is, look at here, that is maximize function is 50x plus 120y, because x is for 50, that is 50x, and y is for 120y. Now writing the constraints. It is given that the farmer has a total budget. It's a $10,000 is a constraint. The cost of producing wheat and barley per hectare is also given to us. We have an upper cap of the total cost spent by the farmer. So our equation becomes, the constraint equation is 100x plus 200y equal to $10,000. Next, the constraint is the upper cap of the availability to the total number of man days for the planning horizon. The total days, number of man days available is 1,200. As per the table, we are given the man day per hectare is 10x, that is 10 man hour for x, 30 man hour for y, that is 10x plus 30y is lesser or equal to 1,200. The third constraint is a total area present for plantation. The total available area is 110 hectares. So the equation is x plus y, because x is for wheat and y is for barley. Both together area is 110 hectares. That is x plus y is lesser or equal to 110. the non-negativity restriction. The value of x and y will be greater than or equal to 0. This goes without saying. X is greater than 0 and y is greater than or equal to 0. We have formulated our linear program. It is LPP program, solving LP throughout the graphical methods. Now look at this. Here we have to draw the graph for this. This is for x axis, this y axis. Now x is for wheat and y is for barley. Now look at here. First we have to draw the graph, that is x plus y is equal to 110, means put x equals 0, y is 110, and put y is 0, x is 110, then draw this line. Now put here x plus 2y equal to 100, put x equals 0 means y is 2y is 100, y is 50, that is x is 0, y is 50. Put x equals 0 means y is 50. Put y equals 0, x is 100. That is y is 0, x is 100. Here x is 0, y is 50. Here this line. Now third line is x plus 3y equal 120. Put x equal to 0 here, y is 3y equal to 120, y is 40. That is x is 0, y is 40, this line. And next here put y is 0, x is 120, this line. This here we draw three lines here. This x plus y is 120, x plus 2y is 100, x plus 3y is 120. Now the feasible solutions, this is suppose we are shading downward, and constraints x constraints y constraint is upward. All the feasible solutions are here. This is the blue area is feasible solutions. That is, you can write that what are the points are here. Look, first this is 0 0. Next is 0 40. X is 0. 0 40 and 0 40 and 100 0. And this point is 60 and 20. This point is 60 and 60 and 20. These are the 4 points. This means here this 60 and 20 here. Now these are coordinate points we got. Now R is an open source tool that is very popular among the data scientists here. Now we'll put the values, the maximum. Look at here. Here if you are using these values 0 0 0 40 100 0 60 20, and among these values if you put x is 0 20, 60 and 20 gives the maximum value. Suppose we are putting 0 0, maximum 0 comes, it's not useful. 0 40 means here if you put 0 and 40, 120 into 40 is something, and 50 plus adding is some number will come, but maximum will come for 60 and 20. You can check. That means 60 5 50 into 60 plus 120 into 20, that is y value, this x value, that is total profit is, maximum profit is $5,400. That means this in this feasible areas, this point is the maximum possible point. So here maximize the profit. We are using that point here by substituting the maximize is it equals 50x plus 120y. X is 60 and y is 20 gives maximum values. By this we can find the maximize the profit. Now next question. A toy manufacturing organization manufactures two types of toys A and B. Both the toys are sold rupees 20 and rupees 25 and 20 respectively. First toy A is 25 price and selling price is 20 for toy B respectively. There are 2000 resource units available every day, from which the toy A requires 20 units while toy B requires 12 units to manufacture. Both of these toys require a production time for 5 minutes. Total working hours 9 hours a day. What would be the manufacturing quantity for each of the toys for maximize the profits? That means this is a toys here, not pipe. Now look at here. This objective function is maximize function is 25x plus 20y, because look at here, rupees sold at rupees 25 for toy A and 20 for toy B. That maximize the profit is 25x into y. Here x is number of toys, y is number of toys B, where x units of here 20x plus 12y is lesser or equal to 2000. 20x plus 12y, that is 20 unit for toy A, 12 units for toy B, and which is equal lesser or equal to 2000. Second one, 5x plus 5y equal to 540. 5x, that is minutes, number of times taken for producing A and B, that is 5 production of time of 5x, and toy B also 5y, total time available is 540 hours. Now first equation for 20x plus 12y equal to 2000, we are dividing by 4, we get 5x plus 3y equal to 500. Second equation as it is, 5x plus 5y equal to 540. So put here x is y is 0 means x will be 100, that is 5x equal to 500, x equal to 100, and put y equal to x equal to 0, y is what happened, x equal to 0 means y equal to 500 by 3, which gives 0 and 167, that is 500 divided by 3 approximate. Here second equation, put x equal to 0, here y is 5y equal to 540, y equal to 108. Put y equal to 0, x becomes 5x equal to 540, x equal to 108. Now we are having these points for two equations. Put the first point here, 100, x equal to 100, y equal to 0. Here x equal to 100, y equal to 0, this point, and the second point, x equal to 0, y is 167. Now join these points, it gives the red line. Similarly, x equal to 0, y is 108, x equal to 0, y is x equal to 0, y equal to 108, and y equal to 0, x equal to 108. The second point we substitute, we get this blue line. And x is greater than 0 here, y is greater than 0 is here. So suppose we are shading regarding the given condition. Now, that these feasible solutions are these areas. Here, this point, this point, this point, and here. Therefore, feasible areas we are having here first 100, 0, this point, and here this is x is 88, 88, x is 88, y is 20 here. This is x is 88, y is 20. Then this point is 100, x is 0, x is 0, y is 108. This is 0, 0. You can write 88, 20, and 0, 0. And one more point is 0, 108. 0, 108. These are the feasible points. These all points include these areas. Means here this to this to this areas. So this is the feasible areas. Now let us substitute the value of z equal. Look at here. Z equal 25x plus 20y. Here, if you substitute in this here these four values, among these four values we have now 88 and 20. This is one more point. This point is here. Totally, these are 88, 20. This 0 or 67 will not. Here, these are the four. These are the 4 points are feasible. In this, we are putting the values. Look at here, 25, x is 88, x is 88, y is 20, which is equal 2200 plus 400, which is total equal 2600. Therefore, maximum profit equal rupees 2600. So far, I have done how to do the graphical methods of LPP problem, and we explain further about the methods we have done. Please subscribe our YouTube channel.